Okay. Wait a sec. Yeah, so next speaker is Dario, speaking more TuRTLe. Thank you.
Thank you. So hi, I'm Dario, come from BSc. I'm here to present TuRTLe, which is essentially a framework for evaluating LLMs for RTL generation. So this is a collaboration within BSc. So this is mainly two teams. There's the hardware team, which is led by Miquel Moreto, and I guess some of you might know him because he's of your community. I'm the lead of the AI team in the computer science department, so I'm kind of an alien here, but it's really nice to be here among you. So I'm going to present what we've been doing for the last year. The goal is, in the end, to produce better models, to try to develop and train better solutions for hardware designers in-house and the rest of the community. But before we can actually train and develop something, we actually need to know what we are doing. So we need to measure, be able to measure properly and decently what we are developing. So we started by benchmarking. So in the evaluation of LLMs, currently for EDA, there are many different tasks and many different ways of measuring performance. And this is one of the issues, that everybody's doing different things. The landscape is very fragmented. So, and there's many dependencies on private tools, on the available benchmarks, and there's a lack of consistency and coherency on how things are being measured. So we kind of try to unify this under TuRTLe. We started by tackling only 3 tasks. The idea is to move forward and incorporate more tasks in the future. But we started with the simplest, which was just RTL generation. So the 3 tasks we first consider is line completion. This is your typical coding assistant task, in which the model is given a piece of code, and it has to produce the following line. Then the second task is model completion, in which essentially you give only the model header, and then the model has to produce the model code, the module code. And finally, we have a specification to RTL, which is similar to model completion, but instead of having it, you have it in natural language description, which is something easier for humans to produce, and so it's something that we would like the models to be able to do. So we have these 3 tasks. We defined standard metrics for how to measure the performance of different models on them. So for single line completion, it's pretty easy. You just do an exact match on the line, and that's it. You can compute an accuracy based on that. For module completion and specification to RTL, there's many different ways in which you can measure performance. We tackled initially these 4, which is first, if the syntax is fine, and the functionality is fine. This is validated with Icarus in the first iteration. Very later, we added it later. And then we also check if it synthesizes and what's the quality of the synthesis. Essentially, we check the performance, the power, and the area. We compare it against the human reference to see if the design of the LLM is actually in par with these PPA scores. So we implemented this under a single umbrella, which is based on eval harness, which is the current standard in the community. We took 4 benchmarks that were already released, and we integrated them. We expanded them to cover all the categories that I just presented. So as you can see, each individual benchmark is pretty small on its own. Even ours, that is an aggregation, is still quite small, 200 samples for syntax functionality, synthesis, and post-synthesis, and 1,000 for single line completion. So it still needs to grow. We apply a kind of cascading evaluation approach, in which we just pass to the next stage if the previous one works fine. So for example, we start with syntax. If it passes syntax, we go to functionality, which is based on the tests that are implemented. Then synthesizability, and whatever is left at that point, we check the post-synthesis quality. So this means that our scores and our performance see how the performance is degrading step after step, and we see how far each model can get. So to do the benchmark thoroughly, we considered all sorts of open models. This is a limitation currently in the field. There's not a lot of thorough benchmarking, and a lot of people just focus on the proprietary models from OpenAI. So instead, we went for open models. We tried base models, so it's just next token prediction kind of stuff. InstructTune, which is fine-tuned on top of base model to answer questions, and then reasoning models. We have this additional inference loop in which they do think, and they produce additional tokens. We also consider general purpose models, so your Llama or DeepSeek or whatever. Code specific, so models that have been trained specific for programming, and then a few models that have been released for RTL code. and then every possible scale. In total, we have more than 40 models. I will show you a bit, and we have an online leaderboard that you can check. So this is not the complete table of results, but to give you an idea of how big this is, we have our general models, the coder models, and the domain-specific, and then in columns we have the different checks. As you can see, syntax is the one that most pass, and then things are more or less stale. So we kind of had to select base models for one task and instruct-tune for others. I can give you more details on that if somebody is interested, because we saw that different kind of models are optimal for different tasks. So one thing is we saw that according to existing benchmarks, syntax is a solved problem. We don't think that's the case. It's just that the benchmarks we are using to evaluate syntax are probably too simple. So we really need to scale the complexity and produce more designs that are challenging to models so that we can actually make them better. Because if we are already saturating the benchmarks, we cannot know if we are actually training better models for syntax. Then for overall, the best model we have found is DeepSeek, which is a really large model, 600 billion parameters. So this is not the typical thing you can run at home. And it has the reasoning pipeline, which makes everything slower, has this loop, so you cannot use it in real time. So it has its limitations. And there's some small models, domain-specific, that are quite decent for the size they have. So this is, we believe, the path to go for scalable applications. Finally, the main drop we see is between syntax and functionality. So as we can see, while syntax we had very high scores, in functionality most models dropped significantly, and then they keep flat. So this means that whatever passes functionality at this point is passing synthesizability and is producing PPA at the level of the human reference. So we actually need also harder designs to check these features. So we released a leaderboard, an online leaderboard. This is updated monthly, so we keep, because there's models coming out every day, we keep adding them here. We run them internally and share them. You can check, and there you can specify whatever you're interested to, what task, what simulator, what benchmark, or what model type you want to look at. And with that, select whatever you think is best for your use case. Okay, so this is what we did. We released, there's a paper on MLCAT with all this. And then the next steps, what we are working on from here to the end of the year, is first exploiting tiny tape out for benchmarking, and also introducing equivalence checking into the pipeline. So to summarize, currently benchmarks, there's a concern about contamination. All code that is online is eventually used for training models, so we are not certain how sure we can be of the actual reliability of these models, of these benchmarks, and the numbers they produce. They are too simple and they are too small. So we thought that we could use tiny tape out periodic shuttles for that. Currently our approach is to take shuttles 6 to 10. We filtered them based on the ones that have the best testing, based on number of asserts, number of signals being tested. Then we thoroughly deduplicate them, because there's a lot of duplicated code in there. And we ended up, in our latest iteration, with about 2,000 designs, which is one order of magnitude larger than what we have today. So that would be a really, really jump in the landscape. We are defining a model completion task, and we hope to release the first release this year. But we also have the goal of releasing, every time Tiny Tape Out releases a new shuttle, our idea is to release a new version of this benchmark so that it's never contaminated, because the models will not be able to have trained on the designs that will be released on the latest iteration. And finally, we are also introducing equivalence checking. Our idea is to do it in parallel to functional check, because functional check is usually limited in coverage. So with that, we hope to give a more thorough and sensitive benchmark on model performance. So for the future, beyond this, we want to expand. This is all RTL code. We want to move forward beyond that, because we know hardware design includes many other tasks. So these are some of the things we are currently considering. Also, the introduction of agentic platforms, like the speaker before me and the speaker after me. I think they're going to talk about platforms, so that's something that we really want to look at, because I think it's really useful for you guys. Eventually, we want to train and develop better models, because that's what's fun for me. Any feedback, comments, or suggestions you have, it would be great to listen to them. So this is the team that work in it, and all the resources. You can check them out, and I'll be around for a couple of days, so come and talk to me.
Questions?
This is, we like it. Okay, question. Yeah.
So are the synthesis check, is that all without context? Just like generate this RTL with no context? Because my experience is it always generates dual drivers, so synthesis will always fail for larger designs.
We provide, so for which particular task you're speaking about?
For going from description to RTL.
The specification to RTL.
Yeah.
No, you're giving, so the rest of the modules are provided. It's just one module is removed, and you have the natural language description for that module. So you, you can infer from other modules.
So no instructions on avoiding things.
Depends on the specification. It's, that's one of the things. We don't have control. I mean, we cannot produce the whole amount of data for producing benchmarks. So if there's data sources, if you guys are documenting that somewhere that we can use, that would be great.
Okay.
I have a quick question. So the models you show, they're mainly the open source models that are available, right?
Yes.
Yeah. Okay. Cool. And how are you running the big DeepSeek one?
In the Barcelona Supercomputing Center.
Okay. In a big server, basically. Yeah. Okay. Have you had a look at the proprietary ones at all? Trying to.
The problem is proprietary models are not actually models; they are engineered systems. So you make a request to an API, and there's one model behind, or several models behind. You never know. And there might be databases and prompt engineering, and I don't know how many things. So it wasn't fair to put it on the same table. We were thinking about producing another placer board for that, but maybe in the future.
I mean, well, yeah, one, because I mean, obviously, like, syntax-wise, system looks very complicated. And one thing I kind of see missing in from the RTL generation is looking at what structurally is output when you're generating something, right? Is it structurally sound? Have you thought about that at all? You know, so you can almost have a multimodal LLM, right, where you've got both the kind of the language level representation and then kind of a more structural representation, because the structural representation will allow you to simulate and understand if it's working, right? So generating code into a structural representation and simulating that could give you a really good data set to train from. And the other question is I can't remember if your team was included in the OSS-CDA in the EU funding call or not. I wanted to check that you're connected.
I don't think so.
That. Yeah, that's a mistake. Unfortunately, I don't think we've got time to fix it, but yeah, because BSC is involved.
For sure,
you know.
yeah. So, yeah, actually, what was the original question about?
Structural representation.
Yeah, multimodal, yeah, right. So, yeah, I think the future is multimodal for sure, but it's another degree of complexity. We are looking at the different modalities and the different kind of ways in which you can introduce data. And we have an ongoing project for that. We have 4 years ahead for doing multimodal on this particular domain. At the moment, it's just, we haven't anything to share on that yet.
Right, Orcom, let's thank the speaker. Out of time.
One last. Okay.
We're out of time, sorry. Thanks, guys.
Time.
Cheers.